All right, welcome back, guys, again. Uh, right. So, first we have to update the like install the Docker, right? So sudo apt update, right? I am filling my answer. As you can see, and okay, now let's install the Docker, right? Let me tell you first something, okay? Let me tell you something first. Which was it? Okay, so what we did here, guys? We did sudo apt update, right? What is sudo here? Like sudo means here that run this command as the administrator, as the root. So I told you yesterday we will never run any getting our file in sudo from the root, right? So this is what root is. So if we are writing sudo, so I think that means we are running it as an administrator. Okay. So when we install software, that will change the system files, right? So normal users cannot do that one. Another is they should not do that also, right? They should not do that, right? So Linux asks, okay, are you sure? And sudo gives the permission. I write my password here, right? This part 2 is apt. Apt is like you can say Ubuntu's package manager, right? So what happens is this package manager downloads and installs software automatically for you. Okay, instead of downloading files and then extracting, then configuring them, right? So here this apt does everything for you. So Ubuntu will do everything for you, right? The update is notice it does not update Docker, right? So it updates Ubuntu list of available softwares. Okay, imagine Ubuntu has a catalog like old catalog. Okay, Docker has 25 version and Python has 3.11 version, right? Like this. After this apt update, Docker will become like their version will update to newer ones. Okay, so no software is installed yet, just a catalog changes. Okay, now what we can do is we will install Docker now. Okay, so you see I say sudo apt install, right? Let's understand. You know what is sudo, you know what is apt, right? So install software means right, install means it is command to install software, right? And I will say yes like this. Why I am writing this why is I can do yes or no, right? So when Ubuntu will ask when this software is being installed, right? Ubuntu will ask me, okay, uh, should I install this file or not? Should I install that package or not inside the software, right? So it will ask you yes or no. So here this y automatically gives you a yes. So you don't have to choose in the middle of the installation, right? Then what I do is I will install docker.io. Okay. So this is just a package name. Ubuntu downloads Docker engine in this case. So let me press enter, right? So package problem solver resolve. What happened? What is this here? Reading package done, building dependency done. So this may mean that you request an impossible situation, or if you are choosing the uninstalled, is that required package have not been created as you. Okay. Let me find out the error. What is this error? Well, I am installing this. Okay. Hello, Zepto, OBH, OBH, OBH आना था ना भाई. OBH आना है भाई. अच्छा अच्छा, 1 मिनट में आ रहा हूँ नीचे OBH में, ठीक है. All right, so yeah, right. So it's saying some error, right? So I think there is a conflict there the following package have unmet dependencies, container IO conflict container. So what happens is, guys, I looked into this error, right? So Docker needs a runtime called container to run the container, right? So there are two packages. One is container, which is provided by Ubuntu, and one is container.io. You see here, right? So container.io is conflicting with container. The container.io is provided by Docker. Okay. But the thing is, from these two, only one should exist. Only one should be installed. Okay. So, like this usually happens, if you have mixed installation sources, right? For example, earlier you installed Docker from Docker official repository, either, right? Or now you are trying to install Ubuntu's Docker IO package, or vice versa. So Ubuntu will see container already installed, but Docker IO wants like container IO, right? So which is conflicting. So I will verify that now. So Docker, let me clear this up first. Docker version, right? So you see, Docker is already there on my system, right? And also I have container version. So container version also there, right? And dpkgl, wait, whatever. Right, wait. So Docker version I have here, and container, right, version, whatever. Version container version, okay, and dpkg l, then I have grep e docker node. dpk, I think it's G here. Alright, we will see this first. Okay. Let me show. Okay, so Docker is already installed, right? We don't need to do it again. Right? So so we have this container also version, right? So this proves that container runtime is also installed here. So why our system fails last time is we have Docker's of shell installation, right? Which is version 29.6.2, right? Now when I run this command sudo apt install docker IO, right? Ubuntu try to install its own Docker package. That package depends on a different package called the container.io, right? Which conflicts with the container which is already installed, right? Now so Ubuntu stop the installation to avoid breaking your existing Docker installation, right? So dpkg, right? This is the correct command, I think. Alright, this is the let me run one more command, docker info. Okay, it's saying something, right? And let me get also one thing, docker hello world, whatever. Okay, so docker run hello world. Alright, so this is the whole scene. Okay, let me put it here in this and here. Alright, that's it. So from this output we can say Docker is working perfectly. The hello world container completed successfully also. Okay, here you can see this, right? And which means when this hello world container returns hello world like this, okay, then that means hello from Docker, right? This is the output here. So this means Docker installation is healthy. Why the earlier was failed, from your package, our package list, you see this uh, these packages, right? ECLI, container. Let me show you. Here, these, do you see this? Everything right here, container and like this. So these are the official Docker packages, right? And we also have this RC packages, which is here, right? Notice this RC container, right? So what this II mean? This means installed successfully. Right? Example, II Docker CE here, right? That means Docker CE is installed. And what is this RC mean here? R means remove and C means configuration files remain, right? So R means removed, container is removed, IO is installed, okay? And configuration files are remaining, but just. So first that container was installed, then it is removed, right? Package is removed, just program is deleted, but configuration files kept. So RC Docker IO, right? Does not mean Docker is installed, okay? It means Docker IO was installed sometime in the past, removed later, but Ubuntu kept its configuration files, right? Yeah. Here it was RC Docker, right? So why was there conflict? So we have this container.io, right? Ubuntu tried to install this container, right? So those are different packages providing essentially the same runtime. Think of them as package A container and package B container.io. Both wants to own the same files, right? So Linux says cannot install both, so installation stops there, right? Like this. And one more thing, we run this docker info, right? So it proves everything is running here. This section server, okay, the server section. You know, it is important one. If docker daemon was not running, you would only see the client. But if daemon is running, then it's also showing the server, okay? So that means client, Docker client and Docker daemon communication is successful here, right? And this Docker hello world is image and Docker run is a command, right? Docker run and hello world is image. So the general formula for Docker command is Docker, then you give some command, then some image name, right? Like Docker run Ubuntu, Docker run Nginx, Docker run Python, like this, right? Now next command we will give a sudo service, okay, docker start. Okay, let me understand this command first. What is service here? So what Linux does, Linux runs background programs, right, which is called services. Like, let me show you. So Linux run these commands like Wi-Fi, like database, right, SSH, like this, and Docker. Alright. So these run even if you don't open them, right? These are the background services. Okay. So this is what Linux does. These keeps running always. Okay. So what happens? These services will run if you don't open them even, right? That's the case. So what is this Docker service then? You know, Docker has two ports. Okay. So Docker has two parts. Okay. Let me show you. The workflow is this. You have a Docker command. It goes to Docker client. Then it will go to Docker daemon, and then it will run the containers. Okay. After that, it will run the container. So what happened? What is the case is the client does not run containers. Okay, daemon does, right? So client will not run container. Daemon run this container, right? So why we need to start this, right? Why we need to start this command, sudo service docker start, right? So this command starts after installation. Docker may not be running, right? This command will start that. Okay. Before Docker daemon may be off. After this command, Docker daemon will be on, right? Let me run this now. It will ask about my this. All right. Now in the background, it will be running. Okay. Now next command would be like this: sudo user mode ag docker $user, or you can say user, right? So this one line is very confusing. Okay, let me write it for you here also. The command is sudo user mode ag docker. What is this? So this user mode means what, right? User mode means that we need to modify the user. Okay. A means the append. Okay. The user mode means modify user. This A means append. Right? Don't remove existing groups, just append. Right? G means modify groups. Right? Then Docker creates a Linux group named Docker, right? Here Docker will create a Linux group named Docker. Okay. So anyone inside this group can use Docker without typing sudo. Okay. They don't need to inside, if they are inside this group, they don't need to type sudo again. User like user here means which the current logged in user. Okay, current logged in user. Alright. For example, this is my username here, right? That is Sunil Jadon, right? So this will be my user instead of user. Okay. So the entire meaning of this command, like I want to create, I want to add myself as a user in a Docker group. Okay. Because without it, every command becomes sudo docker run, right? Sudo, I have to run the common command is for Docker is like this: Docker run some image name, right? Image name. But without that, without this group, I have to write sudo always, right? So to remove this, if I want to only this, I have to add myself in the group, Linux group, right? So Docker run will, so it can like this. Now it's going well. So let me open a new terminal, which is right here, right? So why I am moving to new terminal? Because Linux read your groups only when you logged in. Okay, right? Only when you logged in. Like students, audio, video. After running command, system becomes. If you have groups like, let's say, in Linux you have user groups like this, like students, audio, video, right? After this command, right? So one more thing will be added in this list, which will be Docker as a user, right? Now, but current terminal still remembers only this, right? So we need a new terminal or new group Docker. Okay, now terminal reloads groups. So either I need new terminal or I need to run this command, new grp docker. Now the terminal will reloads the groups. Okay, so if I can do this, it's still fine, right? Now if I do docker run hello world, it's running fine, right? So what was the flow of this command? Okay, I run this command here. This was the command, right? Right. So I run this command. Now what happened? Okay, the client will receive this command. Okay, client, it goes to client, right? And client will ask the daemon, okay, run hello world. This was asked to daemon. Okay, like this. And this daemon will ask, or you can say check, right? Like, do I have all this? Do I have this like image of hello world or not? Right? So suppose answer is no, right? So Docker will contact Docker hub to the on the internet, right, and download the image, right. Then it will store that locally after that. Okay. Then container is created. Image, you have this image, then container will be created. Program inside container runs this hello from Docker, as you can see here. Hello from Docker, right? Okay, this is just message. You're going to pull hello world image from Docker hub. Okay, the Docker daemon created the new content from the image which runs. Okay. So that's the same case, right? So now program is finished, as you can see, but container will exist. Okay. So why this is important for us? This proves our Docker is installed. One thing, daemon is also running. As you can see, Docker hello world we received. Internet is working because we downloaded from the internet, right? Docker hub is reachable. Images can be downloaded, like we already downloaded hello world, right? A container can run because it gave us this. Right? Now next command we will run, guys, is this. Okay. Docker run it Python 3.12, right? Slim Python. So you see, this says unable to find this image locally, then it is pulling from the Python library, right? And pull is completed here, guys. And we are running Python here, right? Here, after installing. So the Docker run will create a container here. And this what is, this is actually two flags. It is not one flag. One is interactive and T is terminal. Okay. So what happens is it will keep the keyboard connected with the interactive I flag, and T means terminal. So it will allocate a terminal to us. Okay. So we will get an interactive cell in this case. It together becomes interactive cell, right? Without this you cannot type here. Okay. That's, you can type here like this, right? You cannot type here. And this Python, this is like a special version of Python image, right? So this is just the image name, official Python image version, which is 3.12, right? A variant of this version is Slim. Slim means like small size. Okay, fewer extra packages, less download, like this, right? And this final Python is, this will, what it will do, this command execute inside container, right? Instead of the base. So this Python is running inside this container. Okay, which is created for the for this Python image, right? It runs the Python. The now REPL is starting, right? REPL means R means read, E means execute, P means print, L means loop. So let me try to run some Python here. I am Python inside, right, a container. Let me try this. So you see, this is writing like exactly this, right? So this is not my system Python, right? My laptop is system Python, maybe 3.10, right? But container is this specific Python, which is 3.12. Okay, so this is completely separate, right? Nothing interferes here. So if I do exit like this, so what happens here, container will stop in this case, okay, and this isolated environment will disappear, and that's why people also call containers disposable. We can dispose them, right? Next command will be for us is docker psa. What is ps here? PS means process status, okay. In docker it lists the containers for us, okay. A means without a docker psc only. So you see, so container id, image created, status, port, there is nothing. So what happens, docker ps only shows the docker image which are running, but if I add a, okay, so this shows the everything, like every container, okay, which is running, stopped, exited, created, like this, okay. You see, the recent image of us is Python. 3 minutes ago we created that, exited 90, like this. So this is the status for us, okay. So ps is process status, okay. So very important command, right? Next command is docker images, right? So it will show the downloaded images. One is we have Python, one is we have Hello World, okay. And the size is also this 119 MB like this, right? So you see, the container has exited, right? We created and exited the container, but image is already always there, right? So we can create and dispose containers anytime, but images will be there in the docker, right? So like recipe and cake will be there. We can anytime cook a cake or bake a cake, right? Now next step is, guys, we have one more thing which is very important also. Docker ignore, okay. So before creating an image, docker copies files from your project. I will be back in a minute, guys, just a minute. Alright guys, so we were understanding this is docker ignore file. So this is not get ignore, this is docker ignore file, right? So before creating any image, okay, docker copies files from your project, right? So you have this your project folder, right? Then this project folder you give docker to docker build, and after that it will create an image of it, right? But not every file should be copied, right? So that's why we create docker ignore. So this is just exactly like get ignore. In get ignore, get will ignore files. In docker ignore, docker will ignore those files. Okay. Like for example, venv slash. So it will ignore this venv. Ignore virtual environment. Why? Because docker already has Python, right? So copying your local virtual environment wastes the space, right? Like this. Generally venv is like something like 2 GB, right? So this is very waste of storage. Like we can ignore this pyksa slash, like Python store compiled bytecode in this. Like you have some file like main.py, so it will, when it compiles, it goes Python bytecode, right? So these are automatically regenerated, so no need to copy them, right? And we can ignore like this pyc files. So it will ignore all compiled Python files, right? Next we can ignore this .get folder also. We don't need git history, right? In Docker, this get contains commits, branches, logs, and objects, everything. So application just does not need them to run, right? Copying git history only increases the image size, right? Next we can ignore some notebooks like experiments, Python Jupyter notebooks, exploration if we have, right? Slash notebooks like this, right? And most important is this .env. So this is the most critical line. A .env file usually contains secrets, right? Like password, API keys, JWT secrets, like this. If Docker copies this file into the image, those secrets become part of image forever, right? So if you then push the image to a registry, let's say online, so anyone with this access to that image can potentially inspect it and recover the secret, right? So instead, so we don't we ignore env files, but when we have to provide some secrets, right? So what we do, we provide secrets when the container starts, okay, from the image at the runtime, not while building the image, okay? For example, we have this docker run e db password is equal to my secret, let's say, and my image, or other command will be like this: docker, right? Docker run env file .env my image. So in these cases, image will contain remains the secret free. Okay, container receive the secret only while it is running. All right. So, so you know how this container will become? Container is image plus runtime configuration, right? Like this. So this separation is a core security principle in Docker here. Next we have models, like we can ignore this models backup. So like old backup models like this large, they are not needed at all, right? So when which is not needed to run the package or run your project, we can ignore all of this. Okay, IPYNB checkpoints like this, right? So because Jupyter automatically create a checkpoint folder, they only store intermediate notebook versions. That's it. So they are very safe to ignore, right? So this everything is working. So should I create Docker ignore file also, right? So we have git ignore. I will create one more file called Docker Docker ignore, right? And this so what this declare dot Docker ignore, it says never gets copied to the image, right? So we can do venv and by cache slash and every bytecode of Python compiled, right? And dot git folder also, which is hidden. Notebooks, if one have, we have notebooks. Do we have notebooks folder? Yeah, we have this notebooks folder. And dot env we are ignoring here, and models backup. Right, and right, then one more thing, I can IPYNB check points. Okay, so do we have IPYNB checkpoints anywhere? Not yet, but okay. Right. Now we have this Docker ignore file, right? So let me write a first Docker file view, very simple version. Okay. All right. So so let me create a simple Docker file for you. Okay. Docker file like this. No extension needed. What is the problem here? No source image provided with from. Okay, we will do everything. Okay. So what we do? Capital from Python. Okay, 3.12 slim. Right. So this is the base image. This is our starting layer. Right. Let me do one more thing. So you see, Docker file is one of the most important files you will write in DevOps or mlops. Okay. So you can think of it as a recipe, just like a cake recipe tells a chef how to make a cake. So also Docker file tells Docker how to make an image, right? So first you create Docker file, then you run a command called docker build, then it will create an image, then you run that container, right? So Docker file is a recipe, and image will be like, okay, prepared using recipe, right? Container, someone eating that cake like this. Okay, just terminologies, analogy. Okay. So what is a Docker file here, right? This Docker file is just a text, simply a text file. It has just instructions and instructions. Docker reads it from top to bottom. For example, here from top to bottom like this, right? It never jumps around. So flow will be always line 1, then line 2, then line 3, then line 4 like this, right? And every instruction will create an image also, like image, new image layer, every instruction. So we have this line 1 from Python, this, right? So this is one of the most important line. Without from, right, Docker doesn't know where to start. Okay. So think of it as, just a second, guys.
અમારામાંથી તો કોઈ નહીં ગયું, બાકી એકાદ જણું જો.
Alright, so this is one of the most important line. Okay, so without this from statement, from keyword, right, Docker will not know where to start. So if I see, if I run this, so no source image provided with from, right? So this is giving me a problem. So as long I do this, right, and let's say base image only, so problem is gone, right? But I have to give this because I am starting slim, right, like this. So think of building a house, right? Before building you need land, right? So similarly Docker image needs base image first. Okay, from tells Docker, okay, start from this existing image. Okay, so this Python here, right, we already have this image, right? So this is official Python image version 3.12 and Slim edition, right? So why we are not installing Python ourselves, right? So without Docker image, Ubuntu In Ubuntu, we install Python, like install pip like this, right? Then we configure the path, then we install libraries, and then we run the app. Lots of work are there, right? So instead, what we do, from Python slim, this line already contains this thing. Uh, so without this Docker, what happens? You go to Ubuntu, right? You need to install Python, right? So you go to install pip like this, right? Pip install Python. Then you configure paths, interpreters like this, right? Then also after that install some libraries, right? Then after that you run the app, right? This is case for without Docker, case, right? But with Docker, this one line from Python, this already contains what? Do you know? This contains Linux for you plus Python plus pip. These are all ready to use for you, okay? And why we need Salim here? So imagine you have three bags are there, right? So when you install full image, that contains 1000 MB. Like it contains Python, compiler, documentation, examples, right? Debug tools, right? Many extra packages left. But Slim is only for like 150 MB. It only contains Python, pip, and very minimal Linux for you. It does not contain unnecessary things, okay? Okay, and now next line for us would be like this, guys. Okay, work directory. The work directory path we get slash f. Okay, because we are for creating this file in root, and we have this slash f ui.py. We will start everything from here, right? So working directory will be this, and right there. So in general we need to reach the project file, right, root folder, right? So here like user AI we have to go to the root of the project to run service. So this is also need Docker also need this working directory path, right? So if this folder does not exist, Docker automatically creates it. It's very convenient. Okay, without working directory you when you do copy files like this, right? So Docker doesn't know where dot is, right? So next line for us will be this copy requirements.txt, right? Requirements. So copy, copy means copy the files, right? Txt. One more thing is dot. Okay, why this dot I will tell you. So copy means copy files, right? And this is the source from where we have to copy, and this is the dot, which means the destination. So remember we this is working directory app, right? So dot means slash app, right, here. So results requirements.txt from the laptop will go under here, cell in the app. Okay, here requirement.txt will be copied here. Okay, now so why we only copying requirement.txt, not like any other files, right? So this is one of the Docker's biggest optimization. Suppose project is this, right? Let's say suppose our project is this. We have app.py, right? We have api.py also, right? We have utils, let's say utils.py like this, and we have requirements.txt. So every day you will change api.py, right? You almost never change this requirement.txt, right? So Docker remembers previous layers, right? Like layer 1 is Python, layer 2 is requirement, layer 3 will be something else, layer 4 will be something else, right? Source code. So tomorrow only you change this api.py like this. So Docker compares old to new, right? So layer 1 will be same, layer 2 will be same. So it will last layer, the code layer will be modified. Then only the Docker will build only that layer. If first or second layer is modified, right? Modified, then Docker has to build rest of the layers again. Okay, that's the case. So this is like whichever changes list, we have to keep that up, okay, in the order. Now we have to run this, run pip install, right? No cache dir or requirement.txt. Okay, what is this? So pip, you know what it is. This will install our Python libraries which are in this requirement.txt, right? All of these, you see, all of these libraries, and run will execute this command, which is this command, right? While building an image, so when you build an image, this command will run. So right, there are two times. One is build time, one is run time, right? At build time, run will be there, but at runtime, this run will be converted to cmd command. So people confuse this. Okay, so remember, run is for image creation during image, cmd is for container when the container start. Okay, so this pip install suppose requirement.txt contains these fast API, numpy, pandas, like this Python libraries. As you can see here, very much fast API is there, right? And HTTP is there, and Pydantic, I think, Jupyter is there, Matplotlib is there, Pandas is there, right? Pydantic is there. So many things, and Streamlit is there, right? We have this. So Docker will execute these commands, and it will download all of these libraries. Okay, this will download all of these libraries. R means here read package names from file, right? We have to this R means read package names from the files. Instead of pip install fast API, pip install numpy, just read this, right? What is no cache directory here? Normally pip stores downloaded packages, right? So when you do pip install numpy, so what pip does, it saves a copy of the numpy, right? Then it goes to next install, right? It uses cached copy. Okay, that's useful for your on your laptop. Inside Docker image, cache is useless. Why? Because image is immutable, right? It never changes. So keeping cache only wastes space. So without cache, we have 150. With cache, we have 220 MB. So no benefit of that. Next is we have copy by project.toml. Alright. So this is also copies to in /app. So what is this PyProject.toml? As you can see, it describes your package. Okay, like it contains what it requires, right? It requires setup tools which is got version greater than 68, like this, right? It contains project name, it contains version, dependencies are there, right? Build system, everything. Next line is here Docker file we have. Next line is copy /src/c/. Okay, so what this means? So it means we have to copy this entire source folder, which is here. You can see this is the source folder, right? With it has inside package also, right? In the image, with source folder name. Okay, copy this folder with this name. Okay, like this. Now we have it's like this, it will be like this. Now we have this /app/src, we have two folders now, right? Next we have run pip install no deps e, right? So let's break it. You know what is pip install, right? Pip install is like editable install. Okay, usually this is just pip install dot, but it just copies the packages, but editable creates link. So it is very useful during development. Dot means current directory, right? You know, current directory is /app because and no dependencies means do not install dependencies. Why? Because earlier in requirement to TST already install everything, so we don't need to install dependencies, already install everything, so no need to repeat. And this editable means when this will create a package of this you know, in the TML5 project TML file, whenever it creates the project of source, whenever it creates the package of this, right, it will create links, so we don't need to rebuild it again and again whenever we change this here, right? So that's why editable here, right? Next line for us guys will be copy models in models folder, like this, right? So it will copy this trend model here. From here we have this models, right? Models folder. It will copy trend ML models because your API needs model files, right? So without them prediction won't work, so you need them also, right? So for now we are doing this, but in future what we will do, we will create a model registry, and at runtime we will download these models. So instead of storing inside images, right? Large companies, what do? They don't bake models into images. They download latest approved models. Okay. Next we will have this copy configs/configs, right? So you know this configs, we have train.yml, and so we also need this for our configurations, right? YML files. And our you know, trend.py, you know, everything is coming from config. Yeah, we are importing YML, and we are reading the config file here, like this, right? YML safe load, like this. So everything is coming from the config file here, right? And Docker file is we are building, so it will copy the configure files, right? Next will be expose port. Port is our, what is our port? It is 8000, right? So this is very misunderstood topic. People think expose means open the port. That's not what it means. So people think expose means open port, right? Which is not a correct idea. It only documents, okay? Application listens here. So you can think of like expose as just a nameplate. Okay, like room number 8000 like this. It does not unlock the door. Just a nameplate is there. Room nameplate. Right? Actual opening happens during Docker run. Right? Without. So what happens when you do this Docker run P 8000? Right? Without P, nobody outside container can connect. Right? So what happens is, so you have a container and it is on port 8000, right? And this is outside world, right? But when you do with P, this 8000, so what happens is your laptop at 8000, a container is also 8000. Okay, so last line for us guys in this Docker file will be this cmd, right? Fast API, right? Run src slash review radar slash dot py. Okay, then you have port, then you have 8000. So this is the startup command. Okay, so when container starts, Docker executes this according to this line, right? According to this line, Docker will do? Right, according to this line, Docker will execute this line, fast API, right, slash run, no, wait a second, fast API, then run, then src slash review radar slash api.py, right, then port 8000, right, automatically. So difference is like this is like run, so this is during build, a cmd during container execution. Okay, and so why this JSON form here instead of just writing like cmd python app.py like this? Because JSON form start process directly. Okay, Docker then Python. Shell form, what happens? It goes Docker, then goes to shell, then to Python. That's why we need a JSON form here, right? Extra shell causes signal handling problem, right? When stopping container, Docker stop, Docker sends sig term JSON form, Docker Python, then graceful shutdown there, right? Shell form sometimes Docker, then shell, then Python, signal is lost. So Kubernetes relies on proper shutdown. Okay. Now what we will do, let me so should I build this, guys? So, first let me go to your source vemv link wait. Okay, now should I build this docker build, right? T review radar API. Okay, so D9 is to do this D9, right? So what it will do, it will build the image from the docker file, t names, and it takes it. Okay, so name will be review radar API.9, and at the end dot will tell like is a build context. This folder is what copy can see. Okay, by dot ignore expected layer by layer progress, right? So docker build will create the image. T is for tag the image. Without tag, image gets random ID, right? With this, it will get this easy to use ID, like this ID for the image. Structure named as colon tag. Okay, so this is name and this is tag. Okay, and final is dot. This is called the build context. It means like current folder, or if we want to build context to different folder, we have to give the path for that folder. Okay, Docker can only copy files inside the build context. Okay, whatever we give the build context, Docker can only copy the files from there. Okay, so everything is inside this folder, so we can rely on this. So files excluded by .ignore are filtered out before they are sent to Docker, right? Why? So why does the second build will become very fast? Suppose the first build creates these layers like Python, working directory, everything, right? Like this, right? This is layers, right? On the next build, if nothing changed, Docker compares every instruction and its input. So the build may finish only in a few seconds. Now suppose you edit only api.py, right? So requirement.txt is unchanged and source/api.py is changed. So Docker can still reuse the earlier layers, right? Like this. Alright, so yeah, that's it. Then we have so should we build the image now? So building 0.1 second finished. Internal load build definition from Docker file. Transferring Docker file to byte. Error failed to build, failed to solve, failed to read Docker file. No such file directory. Okay. Why not? It is there. Why is it's a review error? What happened? Docker build review radar AI remind okay, let me resolve this issue first, right? Why is this error? Okay, so my Docker file is in virtual environment. Wow, what go to the moment. So it's all outside. Okay, thank God, it's outside, right? It's now building. Now what happened? Then again one error. So alright guys, I have to remove this line from requirement.txt. Okay, here. Alright, I think now I can do this. Docker will write a line here. You can see. Then You see the layer by layer, this is building, right? First from Python like this, Python, then we do working library directory, right? And then requirement copy, then it's installing. So it's building layer by layer, right? So first build will takes couple of minutes to install everything, right? The cache will pay off now. So do this to okay, it will take some time. To that I will do something for now. You can see guys, it's taking some time here, right? हेलो। ब्रेड की पैकेट है, खोल रहा हूँ। हम्म, 30 तारीख थी एक क्लास स्टार्ट। हम्म, बालक आएगी, अपनों बालक उज्जैन घूम रहा हूँ। हम्म, 3 तारीख को आ रहा है। हम्म, हाँ बढ़िया चल रहा है काम से। बढ़िया चल रहा है, बीटेक वाले बालक आ रहे हैं आज के। उनके मैया बाप आ रहे सब, उनने कॉलेज दिखा रहे बालक। यही कहानी चल रही है बाहर तो। हम्म, हाँ ब्रेड, दोबारा भूख लगी, ब्रेड खा रहा हूँ। अरे 2 ही खाऊं पूरे दिन में। 2 ब्रेड पीनट बटर लगा के। हाँ जो भी है। हेलो बुआ राम। बढ़िया है। हाँ अच्छा, का है वो, वही एक का है वो, ज़्यादा ज़्यादा दिक्कत है गई। हम्म, है वो। अब मैं ऐसे बुलाए पर तो अब ना हूँ मैं तो, जब जब जाऊंगा एक पोत बुलावेगी जब। अब रोज रोज बुलाए पर मेरे को कैसे आऊँ बताओ। हर बार फाइनल कुश्ती पे। अब मैं क्या देखूँ, होनी है वो तो होगी। हाँ, और अरे अब कहाँ टाइम लगे, अब तो नेक में आ जाए हैं। वह 12 में तो पहले आ जाऊंगा। ना आवाज नहीं कर रही लगे। अरे निकले। अम्मा, राम राम। हाँ बढ़िया है। हाँ रोटी पानी खा रहा हूँ मैं तो, बढ़िया। हम्म। अच्छा बढ़िया। हम्म, खिचड़ी में थोड़ा सा घ्यो डाल दो तो नहीं। कि आर पार की कुश्ती थे पहले, क्या तो आर या पार। घ्यो डाल के बढ़िया तरह। हाँ के के तो जेल जाएगी क्या फिर। और क्या नहीं। हाँ ऐसे ही काय को रोज रोज इतने को डुला में। छुट्टी बुआ छुट्टी तो ना है। अब खत्म ही भई है छुट्टी। राखी बंधन पे पीछे आएंगे अब ये दिवाली पे शायद बन जाए चांस। हम्म। हाँ हाँ। क्या करें क्या करें। अब सुरतागी का काम चल रहा है। हाँ जी। मजबूरी यही और काय को आए यहाँ। बिल्कुल। हम्म। और बढ़िया। आओ दोबारा खा रहा हूँ। हम्म। है। हम्म। कहाँ खाना तो खाना खाना तो है वो 7:30 बजे ही। अब तो पेट भरो जा रहा हो बस। अब तो पेट भरो जा रहा हो बस खाना तो है वो पहले ही। हम्म। अब हम्म। परसों आओ। उज्जैन मंदिर में घूम लो दर्शन कर। हम्म। कल कर दो। कल मीटिंग होगी ना संडे को। हम्म। 2 महीना आगे कर दो। 2 महीना आगे कर दो कल। हम्म। अब मैं ही छोड़ रहा हूँ। हम्म। हम्म। हेलो बुआ राम। हाँ बढ़िया। कछु ना है तो ब्रेड ब्रेड सी खाए भी लग रहा हूँ पेट भर भी। हम्म। मैं करूँगा ही ना। हाँ। आओ आओ, मैं कर रहा ही ना रहा हूँ। हवा की हाव ना करी, मैंने अपनी बात करी है। अभी तो बहुत टाइम है, क्योंकि दिसंबर जनवरी तक तो ना चल पड़ेगी क्या, तो बाद पीछे ही आ जाएगा। दिसंबर में छुट्टी पुट्टी हो जब भी चल पड़ेगी। हाँ, मन पन तो सब लग जाए अपन को। हाँ, सब लग जाए काम। ना रक्षाबंधन की तो जहाँ से आते एक दिन की छुट्टी हो जाए बस, ज़्यादा छुट्टी ना हो। व्हाट्सएप पे फोटो भेज दियो। हाँ, ये कई बात है, बात कहा है, मिल जाए। कब को और क्या बंधन सो? तीन चार में। हाँ तो अभी तो बुला देना। अरे यही तीन चार में है क्या? यही तीन चार में, अगले महीना में? हाँ तो अभी दिन है। हाँ वो सोंग वही है, 12 साढ़े 12 बजे सो जाऊंगा। हम्म। हैं? ना, एक वहाँ तो बार तो खाली हो सदोशी। अब फिर सुबह तो पहले ने ऐसा भूख लगे आ गए जाकर, तो जहाँ रात हूँ घबरा में कछु ना कछु कर गया। हम्म। हो। आओ, ठीक ठीक है। Alright guys, so it's installed, right? Now, so it took like very much time, right, in installing, right? Now let me try to run this command again. So it doesn't take time, right, because it cached everything. Everything is cached, right? Now let me do one thing. I will change only one little in here. Let's say I will add some comment here. It will create, initialize the database and create the prediction table. I have changed it. Now if you see here, if I run this command again, so now everything is cached, right? But this copy and pip install dependency, right? So this is taking time, so it is building again, right? So that is the right. So layer order is not paid entry, right? It's your daily build speed, right? So how your build will speed up. Now let me run something. Docker run p 8000, right, like this. In v file we will give a .env file for the configuration at the runtime, right, to this image. Review radar pi day 9 is the tag, right? You see starting fast API app here. What is error now? Okay, let me try to run this. Sudo system will start. Now I think it can run, right? Like this, it should run now, because that is running, the database is running now, right? One thing, and second thing is this. Let me do it again. It's online, right? It's not seeing down. It's online. So let me show it to it. Your architecture was this, okay. Localhost means how you want to machine everything works. After Docker Active Storage, Ubuntu machine PostgreSQL is there. Your Docker container fast API localhost. Okay. Inside the container local means container itself. So not Ubuntu machine is local and trying localhost. Okay. So why does Docker is doing this? Every container has its own network namespace. Okay, so think of it like every container getting its own tiny computer. Alright, so each local host is different. So how to fix it? Open recommended for Docker desktop example. Run the container like this. Docker run localhost internal host. Okay, this change your .env to then change your .env to this. Now container, okay. Production way. Run Postgres in another Docker container using Docker Compose. Then your URL becomes where Postgres password is Postgres. Run Postgres in another Docker container. So for now we have to, I think, do this, right? Alright, so I am doing this .env file. Where is .env file? .env file, right? No. Database URL is this. Alright. And next I have to run this through this command, right? Docker run like this. But before that I have to build the image again, right? Because I think I have messed it up like this. Okay, now I am running. Also I can run this here. Okay, now I can run this command, right? Okay, we will look into it tomorrow. Okay, thank you so much for watching, guys.